we continue by solving question number 45 to question number 55 of year 2010, which are basically numericals. So I'll be solving all the numericals present in the question paper and not like dividing them into like services part or the housing part. So when you solve all these different numericals in one sitting, you'll understand it better. You'll understand, okay, this formula, this thing. So that's why when you solve all the like one separate part like housing, you solve all the housing, it can get a little bit mashed up. So we start with question number 45, and in question number 45 there's a diagram given basically. So I'll just draw this. So this is basically the diagram which has been given in question number 45. I'll read the question. In a display window of height h is equal to 8.66 meter. This is 8.66 meter of a retail store. A luminaire of intensity L is mounted at a distance L is equal to 5 meter. So L is 5 meter away from the rear. Its light beam is cast at an angle of 45 degree from the ceiling as shown in the figure alongside, and we have to find the ratio of illumination at points P1 to points P2. So basically here we will use a formula which is known as, Lambert's cosine law. This is your lighting and illumination part. So I'll list all the formula in the last, like in last of the video, in one of the videos I'll list all the formulas present in different sections. So Lambert cosine's formula basically states that for any illuminance falling on a surface with angle of incidence theta, E naught is equal to E cos theta. So this is basically what Lambert's cosine law states. Now lighting is also like this, E is also which is illumination, is also intensity by distance square. Which is I by d square. The unit is lux, so lux is the unit. Now putting this in this, so I'll just also draw like a box around this. So basically putting this into this, we get E naught is equal to I cos theta by d square. Again, now coming back to the question, E is illumination at a point. Okay, E is basically what we have to find out, illumination at a point. I is intensity, d is the distance, and theta is the angle between the source and the point. So in the same way we write for like P1, illumination at P1, it will be intensity. We don't know the intensity, so it will stay as I, and we know cos 45, it will be cos 45 degree because 45 degree angle is made on P1. So I cos 45 degree by d square, and then you can keep it d square only because the distance is same, so which L is same, so basically you can 2, and then P2 will be I cos 60 degree by d square. So obviously if you have to find the ratio, it will be P1 by P2 will be I cos 45 degree by d square into, this will be reversed, d square by I cos 60 degree. I cancel, d square cancel, it will be cos 45 degree by cos 60 degree. Cos 45 degree is your 1 by root 2 and this is your 1 by 2. So solving this, we will get, like, I'll just simplify 1 by root 2 into 2 it will be, and then it will be, so this will cut from root 2, so it will be root 2 by 1, which will be the answer. Root 2 is to 1. So this is basically how you solve the question of lighting and illumination, and you can see from one question only we have gotten information about 3 different formulas. Question number 46 is of your CPM and POD question. So like, if you have, I will draw the diagram even if you know the diagram. So we have, the diagram is basically like this. So this is activity 1, this is activity 2, and here we have activity 3. So in question it's given that normal duration for activity 1 to 2 is 3 days, for 2 to 3 is 4 days, for 2 to 4 is 5 days, and for 3 to 4 is 7 days. So this is the normal duration, and the question has also mentioned crash time. So 1 to 2 is 2 days, then 2 to 3 is also 2 days, then we have 2 to 4 as 4 days, and 3 to 4 as 5 days. I'll write it here. So basically we know we have to find a critical path first. So critical path basically means the path which has the longest time, so that it can allow for delays also. So we'll just, there are basically several paths. So first we'll see, like, it starts at 1 and ends at 4, so we can have first 1 2, like 1 2 3 4. So 1 2 3 4, what is the time required? So 1 2 3 4 5 6 7 8 9 10 11 12 13 14, so 14 days. If we follow like this, we can also follow 1 2 4. So if we are following 1 to 4, so it will be 1 2 3, and we are only calculating the normal duration, not the crash duration right now. So 1 to 4 it will be 1 2 3, then 1 2 3 4 5 6 7 8, so you have 8 days over here. So the critical path will be 1 2 3 4, which is like 14 days, and crash time, this is crash time. So crash time means the number of days the project will be completed in minimum, like the minimum time required for completion of project, or the crash time basically. So this will be on critical path, the time, crash time mentioned on critical path, which will be 2 plus 2 plus 2 plus 5. So it will be 1 2 3 4 5 6 7 8 9. So it will be 9 days. Coming to the next question. Question number 47 was a marks to all question. There was something wrong with the question, so I won't be doing that. Question number 48 is shear force diagram and bending moment diagram, and I'll tell this like in the structures video in a bit of detail, but you can just this is an easy question. You can understand like how the shear force and bending moment diagram works. And then we come to question number 50. Basically we have a question which is divided into two separate parts. Question number 50 and question number 51 have the same details. So a plot of land is to be developed as a residential neighborhood. The key development conditions and project requirements are given below. So we just write plot area, which is 1.25 hectares. You should also know that this means it is 1.25 into 10,000 square meters, which will be 12,500 square meters. Now FAR, maximum permissible FAR, is given as 350. Whenever it's looking like 350 or 3.5 is the same thing. So basically for future we'll just take it as 3.5. This is just to like, this is how it's represented. It can be like 200, but the FAR which we'll take for calculations will be 2 only. So ground coverage 30%. Ground coverage means like if you have a plot area of x, so ground coverage is the percentage of x in which you are allowed to build. The rest has to be open. And maximum height will be 45 meters. Density of population. So density of population is 800 ppha, which means people per hectare. An average household size. Household means like there's this one one unit where people live together and they share meals with the common kitchen. So like if you're living in a hostel, if you're living in a college hostel, that becomes one household. Although there may be like 300 people, but because they are sharing meals with the same kitchen, it becomes one household. So 3.55. This is the average. 3.55. Also, like what we understand, what we get from all this information, like for example maximum height. So we know that one floor height will be 3 meters, so this will be like 15 floors of each 3-meter height. So that will be your 45 meters height that will be achieved. And like your density of population is 800 people per hectare. So what it means 800 into 1.25, because we have the plot of 1.25 hectares, which means 1000. Now see, we have the population given, we have the average household size given. So this is like one dwelling unit, you can understand. So total dwelling unit we'll find out. Total dwelling units will be the number of people and the number of like the average household size. So this will come as around 282, approximately 282. This will come as 281.69 and we round it off to 282. In the question it's also given that like we have different building types. So we have LIG, MIG and HIG. LIG is low income group, MIG is medium income group, and HIG is high income group. So LIG will have percentage of dwelling units here I'll mention, and total built up area. So percentage of dwelling unit is 20 for LIG and here is 4480 in square meters. Then MIG we have 55, here we have 18,600. Then SIG we have 25, 14,200. So for LIG, and right over here, this is only like the question. This is all the questions only, and we have come to the what we have understood from the questions. So the question number 50 is the total number of dwelling units under LIG, MIG and HIG respectively are. So we have the total number of dwelling units over here, 282. We have what the percentage of dwelling units are allotted to all the income groups, and how like what is the total built up area. So for like that only we'll find out. Like for LIG we have 20% of 282. So this will come around, will again come around approximately your 56. So we have 56 dwelling units. 56 dwelling units and yeah, so we have 56 dwelling units. We are solving question number 50 over here, okay? Remember that. This question has another part also. So we are solving question number 50 for LIG. Then we have for MIG, we have 55% of dwelling units. So 55% of 282 will come approximately 155. Then we have for SIG. For high income group, we have 25% of 282, 25% of the total dwelling units. So this will come as 71. DU means dwelling units. So this is your question number 50, which was asking the total number of dwelling units under these income groups. Now question number 51 asks, with the above data, the covered area of each flat under the income groups are respectively. We have been given the total built up area. So like what total built up area should be. So what will be the data of each flat? Okay, so for LIG again we write, for LIG we have the total built up area given, we have the number of dwelling units, so this will come around 80. Then for MIG we have 18,600 given, which will be divided by the 155 dwelling units. This will come as 120. This is all square meter, remember please, use square meter. And then for HIG we'll have 14,200 is given, and we have 71. This will come into 200 square meter. So this is basically area of each flat under these income categories, and this was your question number 50 and 51. Next we move on to question number 52. Question number 52 is also like important because almost the same question has also come in question number in question paper of 2021. So we will move on to question number 52. So the question was, a person has purchased an old building at a cost of rupees 2,50,000. So we have rupees 2,50,000 excluding the cost of land. The scrap value of the building is 10% of the cost of purchase, and the future life of the building, or basically the life of the building after purchase, future life of the building is 20 years. So first we have to find the total amount of sinking fund at the end of 20 years. So for that we have to understand certain like in sinking fund formula also. But first let's see what we find from the question. So the amount is rupees 2,50,000, which is basically the actual cost. In sinking fund formula we also have the letter A mentioned. That is another thing. This is another thing. This is the cost. So this is the cost of purchase. Scrap value we have been told is 10% of the actual cost. So 10% of 2,50,000, which will be 25,000. And the total amount of sinking fund at the end of 20 years will be. So we have scrap value, we have the actual cost of purchase. So sinking fund or the sinking fund amount will be actual cost minus scrap value. So actual cost will be 2,50,000, which will be minus 25,000, and we will get 2,25,000. Some definitions also have to know what is basically scrap value. Scrap value, like everything, the building also has a fixed life. So it's like, for this example, you have a building life of 20 years. So after 20 years, when you dismantle the building, when you break down the building, all the materials which are like bricks or doors or windows, so they will be sold to the builder. They are not like completely broken down. They can be sold to the builder. They can be given as a scrap, basically scrap. So this value is given as 10%. So basically that is the scrap value. We also have question number 53, which is linked over here, which is if the rate of interest is 7%, then the annual installment of sinking fund will be what? So first we should write the formula. Sinking fund formula is equal to I, or many people write it A also, I S I by 1 plus I to the power of n minus 1. This is the formula. Now what is I, or as many people write it as A also, this is the annual installment. Annual installment means like for sinking fund, like you have something like if you live in a building, so like you have to paint, or you have to uh, fix something, you have to renovate your kitchen, you have to do something. So what is the annual amount of money that you're uh, putting in the building basically? Then S is your sinking fund. Sinking fund, which we just took out, 2,25,000. Then we have N, which is the number of years, which is in case here is 20. And then we have I, rate of interest. So we'll do I is equal to, we have seen 2,25,000 into I. I is 7%, but how do you write 7%? You write 0.07 because it is 7 by 100. So we'll just take 0.07. Then you have 1 plus 0.07 to the power of 20, because number of years mentioned is 20, and minus 1. This will come as approximately rupees 5507. After calculation, this will be like this. The answer will come around something 5,400 something, but you have to see the question. So in the question, this is the closest to the answer that we have calculated. That's why we'll take this as an answer. That was the right answer. Question number 54 and 55 were actually insufficient questions, or insufficient data was given, so it was again marks to all. So in previous years we have seen that in in every year at least there are 1 to 2 questions which will give you marks to all. So basically in 10 years ago it was happening at a more fast rate, like 3-4 questions you have been getting marks to all. So 54 and 55, that was your last numerical problems, so we won't be doing that.